So of course, earlier we looked at the linear function in a bit more detail, coordinate geometry, equations of straight lines, and so on. Now we raise the power by 1, the quadratic function. And we've done a little bit on quadratics already this year as well. So some of it we'll look at that idea again, but relate it to its picture, that being the parabola. So hence the name of the topic, the quadratic polynomial and the parabola. One is the algebra, one is the picture. So let's have a few definitions here. The quadratic polynomial is simply the algebraic expression. It's not equal to anything, it's just a piece of algebra. So ax squared plus bx plus c is the general one. When we make it equal to another pronumeral, then we call it the quadratic function. And usually it's y equals. When we make it equal to a number, then it becomes a quadratic equation rather than a quadratic function. But the ideas can be used for all the different types, and sometimes we end up using the wrong words for the same things and so on. But as long as we know how to find answers, we'll be okay. Well, coefficients, hopefully I don't need to tell you what coefficients are, but I will anyway. So A, B and C are the coefficients. They're the constant numbers in the expression. So C is still a coefficient, even though there's no x there, because theoretically next to it is x to the power of 0, which is 1. But we just don't write x to the power of 0 down. Indeterminate, that's the unknown. Hence the name, indeterminate. We don't know what it is. So x is the indeterminate. We need to substitute values in for that, or we need to solve equations to find out what it is. Roots. The roots are the solutions to the quadratic equation, whereas the zeros are the x-intercepts of the quadratic function. Exactly the same number. Right? It's just technically, when we talk about the equation, we talk about roots. When we talk about the function, we talk about zeros. And again, sometimes we use the wrong word. So we just think of zeros and roots or solutions to the equation. They all mean the same thing. They all mean the same thing. So for example, if you see something that says, find the roots of x squared minus 1 equals 0, it simply means solve the equation. And of course that's a nice easy one. X squared equals 1, so plus or minus 1. So they are the roots. Okay, graphing quadratics. We know that all quadratics will be parabolas when we draw them. Okay, so we know the basic shape. There's the general form. Y equals ax squared plus bx plus c. Now, just looking at the equation, we can get our bits of information about how to draw our parabola. A. That tells us whether the parabola will be, well, technical term, concave up, or I like to think of it as happy, right? Because it's happy because A is positive. See, when we're positive, we're happy. So it's concave up. And concave down, unhappy or sad curve. That's when A is less than 0 or negative. So when we're feeling a bit negative, we're a bit sad, it's concave down. Okay. So that's what A tells us. So by just looking at the coefficient of x squared, positive and negative tells us whether we're happy, sad. Sometimes you can even use your arms too, that's fun too. In the middle of a test, you totally confuse other people. Alright, so C, just like any polynomial, the constant number turns out to be the y-intercept. Okay, so that's the y-intercept. And that, of course, is because y-intercepts happen when x equals 0. So you sub in 0 to all the x values, you're just left with C. The zeros, or the roots, or the solutions to the equation, as I was saying, they're all the same thing. They are the x-intercepts of the graph. So we solve our quadratic to find out where it cuts the x-axis. X equals minus b on 2a. So b by itself doesn't really tell us anything. But when we go minus b on 2a, that tells us the axis of symmetry, the middle of the parabola. Now, the other way you can do that, if you found the solutions, you can also just average the solutions out. Because of the symmetry, the axis of symmetry, it must be the average of the two solutions, because it must be in the middle. So it depends what you've already found on how you go and get the axis of symmetry. Vertex, well, once you know the axis of symmetry, you simply substitute in the y value and you get the vertex. So the x value is the axis of symmetry, sub it in, and then you get the y coordinate of the vertex. Okay. Sometimes you see questions that say, what is the maximum or what is the minimum of this function? So they're not asking for the vertex, they're just asking for the y value. How high up does it go? How far down does it go? So if they ask for that, they're just looking for the y value. All right, let's do one. Y equals x squared plus 8x plus 12. Now, I'm not suggesting you would write all this down necessarily. Some of this is thought process in the head. For instance, I wouldn't necessarily write down a is 1, which is greater than 0. Oh, I know, it's a happy curve. Right? But all right, that tells me it's concave up. C is 12. Again, possibly I wouldn't write it down. I might just plot the point straight away, but I know the y-intercept is 0, 12. So there we go, I'll plot that on my number plane. Let's find the x-intercepts, so let's go and solve it. This I would write down because I've got to solve the equation. X squared plus 8x plus 12 is 0. Factorises nicely. So we get negative 6 or negative 2 are the x-intercepts. Let's plot those. There they are. Right, axis of symmetry. I've now got two ways I could go and find that. The quickest way is to average these two out if I know them. So average of minus 2 and minus 6 is? Minus 4. So I know the axis of symmetry is minus 4. But if I hadn't have done that, then I can use our formula, minus b on 2a, sub that in, sure enough we get minus 4. So either way, or as I say, we could average out the values, we get that. Now, I don't normally draw a dotted line for the axis of symmetry when I'm drawing a parabola. That's just to illustrate my vertex is going to be on this line, because now I've got to find the y value to get the vertex. So let's sub it in, and we get, by coincidence, it's also minus 4. So let's plot the point, minus 4, minus 4. There we are, down there. That's probably enough information now to draw the parabola, because we know it's symmetric. It's got to go through those points. Whee, there we go. X squared plus 8x plus 12. All right. Just say they gave us some information about the quadratic, but not all of the information, and we've got to come up with the equation. So in this case, they've told me, find the quadratic with solutions or roots 3 and 6. Well, I know it must be some multiple, because it doesn't necessarily have to be 1x squared. It might be 2x squared, 3x squared. It has to be some multiple of x squared minus 9x plus 18. Whoa, how did I get that so quick? I'm just looking at the 3 and the 6. Well, how do I come up with those numbers? 18, what's the connection with 18 and 3 and 6? Yeah, 3 6s are 18. What's the connection with 9 and 3 and 6? They add together. Why does that work? Well, think about it in reverse. If I gave you x squared minus 9x plus 18 and said, factorise this, what would you do? You'd say, what multiplies together to give this last number? What adds together to give this middle number? So all we're doing is the reverse. So when I saw the roots of 6 and 3, I said, oh, well, 6 3s are 18, so I know the number's 18. 6 plus 3 is 9, but it's got to be the negative of that. Because think about when you factorise. You would have said, what gives negative 9? So you would have said negative 6 and negative 3, but you would have formed up an equation which goes x minus 6, x minus 3, which has solutions positive 6 and positive 3. Whoa, that was a mouthful. So it's always, you change the sign in the middle there. Add them together, change the sign, that'll be the number in the middle. And as I say, I multiply by a, because who's to say it is 1x squared? I mean, it might be 2x squared or 3x squared or 4x squared. So try another one. It has an advantage with something like this, which looks really complicated. 3 plus root 2, 3 minus root 2. If I hadn't have done it the other way, what I'd be forced to do is something like this, to go, okay, well, it's x minus 3 minus root 2 times x minus 3 plus root 2. That obviously would be how it factorizes if they're the solutions. I'd have to expand the whole thing out, collect terms, gets a bit messy. But if I use this idea, the answer comes out really quick. There it is. Bang. Multiply them together. Difference of 2 squares. You got a plus b, a minus b. So 9 minus 2 is 7. Add them together, because they're conjugates, the roots always cancel out. I've got 3 plus 3 is 6, so it's minus 6x. Got the equation straight away. So there it is. Difference of 2 squares gave me 7. Add them together, the conjugates cancel out, and we get minus 6. And the reason I haven't multiplied by a this time, there's another word there, monic. If you see monic, it means the coefficient of x squared is 1. Coefficient of x squared is 1. This time they told me the roots are 2 and 8, but they give me an additional piece of information. The vertex is 5, 3. Okay. Well, like the first one, I know it's going to be some multiple of 8 and 2 is 16, so I get 16 at the end. 8 plus 2 is 10, but change the sign, so negative 10 is in the middle. But now I can actually work out that multiple because I've got the additional piece of information that it goes through the vertex. So if I sub in the point 5, 3, I can solve this equation for a. I get negative a third. There's my answer now. I can sub in for a. Y is minus a third, x squared minus 10x plus 16. Quadratic inequalities. I like to use the graph to solve quadratic inequalities. We did have a look at these earlier this year, but let's have another look. So we factorize it like normal. I can draw a rough sketch. To solve the inequality, all I need to know is it concave up or concave down? And where does it cut the x-axis? To solve this, I don't need to worry about what the y-intercept is. I don't need to worry about where the vertex is. I don't need that information. So this one's concave up, and it goes through minus 3 and minus 2. It's a greater than, not a greater than or equal to. So I don't include minus 3 and minus 2. There's my happy parabola. So the question is, for what values of x is that parabola above the x-axis? It would be those ones out there. There's my solution. X is less than minus 3 or x is greater than minus 2. Remember, an alternative way of doing that, if you don't want to draw the parabola, once you've found those critical points of minus 2 or minus 3, think of your number line, test some points, see whether you're in between the 2 points or on the outside. Quadratics will always be like that. You'll either be in between the 2 points or on the outside of the 2 points. In this case, we're on the outside. Let's just do one more. I don't like negative x squareds. Ugh. So I'm going to rewrite the inequality. So it's a positive x squared. So I get x squared plus 3x minus 4. Now, factorize that one. I get x plus 4, x minus 1. This time, those points are included because it's an equal to sign there. Colour them in. I have got a, well, it depends which line you're looking at. And this is where you've got to be careful. I always just look at my last line. My last line, it's a happy curve. Okay. So we're saying, when is it below? When is it less than or equal to 0? And this time, I'm in between the two numbers. There we go. Minus 4 and 1. So 8a.